Welcome everyone to CodePen Houston, the very first CodePen meetup in Houston. Very happy to have you all here in person. Really, thank you all for joining us. And hello everyone that's joining via the live stream. First, thanks to CodePen for being such a rad platform for writing and sharing code. It's been such a handy tool for me personally, and the community that's built up around it has just been awesome to be a part of. Second, thanks to L Creative for sponsoring tonight's meetup by hosting us in the beautiful office space and providing some pizza and drinks for everyone. And tonight we have a very special guest joining us. David Khourshid is a phenomenal developer with a wonderful eye for animation. He's currently on the Microsoft VS Code Live Share team, and I've had the honor of working with him on a collaborative coding live stream that we've been doing for the past few weeks called Keyframers. And he's just such a blast to work with and is such a nice guy. And he has agreed to meet us here for CodePen Houston to give a live talk. Hey, David, how's it going?
Hey, good. Can you hear me?
Yeah, we can hear you.
Awesome.
So we've got everyone here, and we are ready to go whenever you're ready to kick things off.
All right. So, as y'all said, my name is David, and if anyone has any questions at any time, feel free to just ask me. Right now I'm a computer and you're a human, so you have power over me to do whatever to me.
And we do have the Twitch chat as well for those that are joining via the stream. So if you have any questions there as well, we can check that too.
All right. Actually, let me go to the Twitch chat real quick. So, all right. So what I want to talk to you all about today is one of my favorite techniques for animations that I found, just because if you think about like how we've been animating on the web so far, a lot of us will reach for something like GSAP or Velocity or maybe Anime or CSS keyframes, which Shaw and I do a lot. But when it comes to reactive animations, we sort of have to take a different approach. So I don't know if the CodePen is on the screen. All right, cool. So I have CodePen Houston and this link to this library called ReactiveX. And so ReactiveX is actually it's a collection of libraries, and its main intent is to bring sort of a standard to manipulating reactive streams. So you could think of it sort of as a lodash or an underscore for dealing with reactive data. Now I keep throwing this reactive word around a lot, so let me just break it down real quick. Over here you see an image where we have an array of values. And if you think about that collection, you get all of those items at the same time, right? But a stream of values, that's different. Each item in a stream comes one at a time. And so let me just do a real quick example before I get too deep, because honestly, if you click that link and you read the documentation, you're going to be like, I don't have enough computer science degrees to understand all this, so I'm just going to ignore it. But the concept is actually a lot simpler than it makes it seem. So let's do this. Let's take the body from the document, and we're going to create what's called an observable. And so an observable is just like that second picture shows, it's a stream of values that come in over time. And so the way we do that in RxJS is we call rx.observable. And then we could create an observable using various methods that it provides. So in this case, we could do from event. And so we take the body and we say we want to capture the mouse move events. Now, obviously, I need to assign this to a value, so let's do const. Call this mouse moves. All right, so right now this is not doing anything, and that's actually a feature. It's not doing anything because it's not going to start listening for events until it knows that someone is subscribing to it or something is subscribing to it. And so the way we do that is just we call mouse moves subscribe, and then we're going to get a stream of these events. And then we can do whatever we want with these events. So in this case, I have a span in the heading. So let's put the X value of whenever I move my mouse to that position. So then we could just do, actually, I'm going to be smart and do const equals document.query selector. All right, cool. So inner HTML equals events client X. And so now, Shaw, if you want to move your mouse around the screen, you're going to see that number start to update. Let me know if you do. Yeah. And so a lot of you may be thinking, like, I could easily do this. I could just do add event listener, mouse move, and then I could do all this already. Why do I need this fancy library? So let me ask you, like, what if you wanted to manipulate these streams of events? Like, let's say you wanted to do a debounce, right? So if I do debounce 300, I think this is the right function. Let me see. Probably not. It's probably debounce time. Oh, that's weird. But anyway, you could, yeah. Here, let's do debounce time. Yeah, and then try moving your mouse now. So do you see the numbers like updating a lot more slowly so that only when you stop your mouse, the numbers are going to update, right? All right. And all we had to do was add one line, this debounce time, and then we gave it like a 300 millisecond thing. So all of those crazy solutions that you already have for like debouncing inputs and everything, it's solved in one line of RxJS, which is pretty cool. So let's remove that and let's actually do some animation. And I hope that everyone sort of understands the concept of like a stream of values, hopefully. I can't see you all, but I'm assuming that you're all like, yeah. All right, cool. Very simple stuff so far. Let's get to the goats. All right. Now we're going, now that we have like these mouse move events, we could do a lot of things with this. So first, let's make this in a much easier to digest fashion. We could use map, just like you would use array.map. And we could take that event and we could say, X is the events.clientX and Y is the event.clientsY. And now we could take that mouse move and let's actually make things move. Subscribe, so we get the position. I have a syntax error. Let's see. Unexpected token. Semicolon. Okay, cool. All right. Here's what I want to do. I want to create this sort of, Apple TV effect where you move your, I guess, your clicker thing around and the thing sort of rotates with the clicker. So I sort of want to create this effect with this goat. And in order to do that, we're going to have to do a little bit of math. So the first thing we need is from the body, we need the client's width and the client's height from the body. And so that's going to give us our dimensions. And so what I'm thinking we could do is we could divide those dimensions in half, and then that will give us like a -1 to 1 sort of position, right? For like, the top and the bottom. So here's how we could do that. Let's start with the X value. So const rotate X. We're going to get the Y position because I know it's funny. When you're going up and down, you're actually rotating on the X-axis, even though you're moving up and down the Y-axis. It's a little weird. Times -50, and plus 25. All right, so this is going to give us a number from like -25 to 25. And so we're taking the current position, our y position, and we're taking the total height. And wherever our mouse is on there, we're translating that from a value between -25 and 25. And so just to show you how that looks, let's do some inline styling. So let's get the card element first. Equals document.query selector card. All right, cool. Card elm.style.css text equals transform, and we're going to rotate x. Now, hopefully, yes, there we go. So if you move your mouse up and down, you're going to see that those stream of values are what's moving our goat up and down. So you can make it say yes, basically. You see that, right? Hopefully it's working on your end. All right. All right, so now let's do the same for the y. Y equals position.x because we're moving on the x-axis, but we're rotating the y-axis. A little weird, I know, with times 50 and minus 25. So hopefully you understand the math behind this 50 and 25. I basically just want a value between like -25 and 25. So, and those are the amounts of degrees that I'm rotating this thing. All right, so now let's do our rotate y. For y. Okay, cool. Now move your mouse around again. All right. Now, if you've seen our screencasts, you're going to know that Shaw and I are perfectionists. We're never satisfied with just the simple results. So, for instance, with this one, when we stop our mouse, the rotation sort of stops really suddenly. And I'm not really a big fan of that. I like it to go smoothly from point A to point B instead of like, just jerking around. So for that, I'm going to introduce you to something called lerping. And so lerp stands for linear interpolation. And that's a really, really fancy way of saying that, let's say you want to go from point 0 to point 1. Instead of jumping from 0 to 1, say you go halfway every time. So you go from 0 to half to 0.75 to 0.875 to 0.9925 and so on and so on. And eventually you'll reach 1. And so we're going to have a lerp function, start, end. And so that you could consider that like our 0 and our 1. And so the x, this is our delta x. This is the distance that we are, from our end value. So n.x minus start.x. And we're going to do the same with y. So for example, if we're going from 0 to 1, at first, our delta x is going to be 1 minus 0, which is 1. And same thing with our y. And so let's also define a rate. Rate equals 0. We're going to do 0.5 for now. This is a pretty big rate, but it's easy for understanding just what's going on. And we're going to return x, which is the start, plus the change. So if we're going from 0 to 1, our start is 0, and our change would be, let's say, half, multiplied by, it would be 1, multiplied by the rate. Start.y plus dy times the rate. I know this is a lot to take in right now. I've even lost myself a little bit. But the point is that this whole linear interpolation thing it's a really, really cheap animation technique for going smoothly from one point to the next, just by going closer and closer to it, at a certain rate. Okay. Now, because right now we're only basing this animation on our mouse moves, we sort of need something that represents a stream of animation frames, like just a constant stream of values. And so we could do that with animation, creating a stream of animation frames. And so there's a little trick to doing this in Rx observable. Rx.observable has this thing called interval. So let's do that 1 second for now. What this is going to do, it's going to emit a value, which is like just a number like 1, 2, 3, 4, 5, over this interval. So each second it's going to go 1, then 2, then 3, then 4, then 5. What we could do is we could combine this animation frame observable with this mouse move observable and sort of, pair them together. And so we're going to call this smooth move. So we're going to take this animation frame. We're going to take with latest from, and I'll describe this in a little bit. Move. So this with latest from thing, and I'm actually going to try to find an example. This with latest from is an operator that takes two observables. So it takes the first observable, the second one, and it lets you combine them. And so whichever observable comes first, it's going to just carry along the value of the last one. And so I'm going to show you an image of that real quick. Let me find it. And this is just going to appear where the goat is right now. I know a bunch of you are lost, but that's okay. The point of it is to just be like getting a cursory glance at what you could do. All right, so let's replace real quick with this. All right, so over here we see that we have a stream of two different, or we have two different streams. And so with latest from, we're going to be taking our first stream, and that's going to be our main stream. And so every time something is emitted from the second stream, it gets combined with the first stream. It's a lot easier to see it visually, what's happening. Hopefully that sort of makes sense. But basically, we're combining animation frames with our mouse moves. So instead of whenever our mouse stops, the entire thing stops, it's just going to keep going. That's the point of all of that. All right. So we have our combined stream, and now we're going to do scan. This is another operator that if you want to dig further into this topic, you could learn about. But what scan does is it accumulates values. So for example, actually, let me do this real quick. I just want to make a really, really simple example because I know I'm probably getting too far into the weeds right now. So let's take the animation frames, which are right now at 1 second. And I'm going to just, what did I do? 1 second. And animation frame, describe. And then we're going to take this, our position element, our HTML equals frame. So you're going to see that every second that's going to update. You see it, just counting. All right, cool. So, we see what's going on there. Now to scan, here, let me do this. Let's take the animation frame, and we're going to scan it. Yeah. I'm just thinking about how to do this. Okay, so here's what scan is going to take. Scan is going to take whatever our let's call it our full value. In reality, it's the accumulated value, and the value. And so what this is going to do is we could take the full value and the value that's emitted, and we could sort of combine them together. So let's just do this. This is probably going to be really, really crazy. And we're going to start with 0. And so you'll see it's going to get a little crazy. Undefined. See, I told you it would get a little crazy. Let's see, what did oh, I have to return. Wow, I'm an idiot. Okay, here we go. All right, so you see what's happening? Now, instead of just changing the value, it's accumulating all of the values and putting them together. And so it's just getting bigger and bigger and bigger. So hopefully that makes Scan make a little bit more sense. If any of you have used Redux, it's the exact same thing as a reducer, where you take an action and the current state and you get the next state. And so that's exactly what Scan is doing right there. So the reason I explained all that is because we're going to scan by taking each one of these values is the move, which is actually let's just see what that emits right now. Actually, you know what? Let's just go ahead and scan. So we take them. Let's do full value, the move, and we're going to return the lerped full value and move. And so let's subscribe to that and see what that is. Smooth move dot subscribe, and then inner HTML equals. Let's see what happens. And I have a mistake somewhere. Yeah, semicolon. Okay. There's no move. It's called mouse moves. Sorry, this is why live coding is great. All right, so smooth moves. It's not really subscribing. Let's comment this out for now. We're getting object, which is definitely not what we want. So let's do JSON.stringify. I promise you this is all coming to like some sort of grand conclusion. Okay, so now if you move your mouse around the screen, go ahead and do that. You're going to see the value updating and just getting crazier and crazier with its decimal values, right? Okay, so that's because it's moving closer and closer to the resting position, so where the mouse is, and it's updating every second, which honestly is too slow. We wanted animation frames. So let's change this interval to 0, which means like go infinitely fast. But let's say, hey, however fast you go, make sure you don't go faster than the animation frame. And that's what schedulers are for. So now if you move your mouse around, you could see that it sort of eventually goes to the value. And that's what we want. So are you seeing that? Cool. Yep, it sells in. So this is exactly what we want. All right. Now we could get to the good stuff. So all we have to do now is instead of this mouse moves.subscribe, we're going to do this smooth moves.subscribe. And hopefully everything just works. Let's see, we're doing this lerp thing. Okay, my rate is way too fast. So let's turn it down to 0.05. And you're gonna see how smooth it works. Okay, cool. Now move your mouse around. All right. So you see how we're taking those values, and instead of just applying them directly to the elements and trying to manipulate everything, we're transforming them through streams, and then we're applying them to this animation. And so that, in a nutshell, is how you could use RxJS for animations. And I know that last part was very hairy, but hopefully this initial mouse move stuff and just using those mouse move values and applying them to styles sort of makes sense. All right, anyone have any questions?
Any questions from you guys?
Will this apply
Will this with videos? Will this work for videos as well?
I'm sure.
You
we have a
put anything in
HTML5 video
that
tag
element, right?
up and ready.
What's that?
You know what? Let's try it. Let's.
so video is an element, it would work.
Right. We're saying that it's just working on any kind of element. Right now you've got it on a div, but you could have a HTML5 video or anything like that in there, right?
Right, exactly, and that's because it is sitting on a div right now. But let's say that we want to, I don't know, take a video, and yes, I am going to try this. We'll see what happens.
Working live. Woo! Look at those styles.
So you could play this video, and yeah, that's actually working. I don't recommend doing this though, because you're going to piss your users off a lot with your constantly rotating videos. But I mean, it's definitely possible.
Yeah. Very cool.
I actually had no idea that would work. So thanks for that.
Trying things out live. That's good. Any other questions on that, on RxJS or some use cases outside of just mouse movement or anything?
I'm kind of curious about application frameworks.
Applications with frameworks like React.
Yeah, for conversations.
Yeah. How would you use this with something like React or Vue or anything?
So I'm glad you mentioned React. With React, there is something called animated. Maybe you've heard of it. It's mainly used in React Native, and it's basically React's blessed animation library for for animations in React's native. And so they sort of operate on the same principle. They don't use RxJS, but they sort of use their homegrown idea of streams of values. And so what you would do is you would define these streams of values pretty much like we're defining them here. And then you would pass them into magic components like animated.div. Instead of just a div, it's an animated.div. And then in your style tag, you would provide those streams of values. And then you would animate that way. So let me try to actually find the React animated link, because the API is very, very similar. And so once you sort of grok like what this API is trying to do, you could easily see how you could apply it to, I'm going to just post it right here. You could sort of see how that could be applied to RxJS as well. So right on the CodePen. So it's right over there. Why didn't I send her this? Yeah. But also I'm presenting something at React Finland next week, which sort of talks about this idea of using reactive values and reactive streams directly in RxJS or React.js. Which, by the way, React is not reactive. They even say so in their documentation. They say that they should have called React Scheduler instead of React, because it does more scheduling than reacting. In the chat, let's see. Nope.
In the stream. So David, when you're getting started with something like this, where you want to react to mouse movement or to the scroll or something along those lines, do you automatically jump into RxJS? Why would you do that over just using the native event listeners?
That's a really good question, and it really comes down to the manipulation of time, which if you're not using something like a reactive stream library, then it becomes more difficult and the code becomes a lot less declarative to do so. Um, have you ever played around, or maybe someone in this room has, but have you played around with the Origami Design tool by Facebook?
No, I've seen it before. It's a motion design / code exporter kind of tool. Is that correct?
Exactly. So what it's based on, it's based on basically patches. So you have these sources where these sources could come from anywhere. It could come from a mouse movement or your finger movement or some other sort of event source. And then these patches which transform these event sources into things that you could just render into other things. And it's cool. It's sort of like a really visual way of visualizing this entire thing. And so by treating these streams of values as just values, like declarative values, it becomes a lot easier to manipulate them and to play around with them and to configure them without needing to hard code anything. So for example, if you were making this and you were using an event listener approach and you just made it follow your mouse, but then the designer got back to you and said, it's a little too stiff. I need it to go smoothly from one mouse points to another, then the code becomes a lot more difficult. And then let's say the designer comes back at you and says, hey, I also want this shining effect. You know how they have in the Apple video cards, where it shines the opposite direction of where your mouse is. And then you're like, no, now I have to add more code to more places. And so just having it in a nice organized approach, even though this is definitely a bit of a learning curve, is definitely advantageous.
So I guess the main thing is separating what the values from what you want to do with the values. So you can kind of pre-process all of these values and then use them after that.
Exactly. That's the other points too, is that instead of saying, when I move my mouse, do this. Instead of thinking that way, you're thinking, when I move my mouse, that's a set of values. That's a stream of values. And I could do whatever I want with those streams of values. Then you take those streams of values and you use those to manipulate or animate or do whatever you want. And then you could go back and say, hey, instead of mouse movements, I want touch movements, or I want it based on audio or based on other streams of data. It doesn't matter where it comes from anymore because you don't hard code it into your event handlers.
And Rx does have some ways to easily combine like touch and mouse where you're not having to do like 30 different listeners and you can unsubscribe them all in one place as well. Is that
exactly? In fact, look, I'm going to do it like in 30 seconds or less. So let's do a touch move thing where we get the touch move events from the body. And of course, we have to map them to the touches because you could use multiple fingers. And so now if I wanted to combine mouse moves and touch moves, so no matter what I'm using, so I can make it work on mobile or desktop or whatever, let's do moves. Here's how difficult it is. We have arcs.observable, .merge, mouse moves, and touch moves. And that's all. And so now all we have to do is replace this with moves, and it's still going to work. But if you view this, I don't know if you could like change this to debugger. Can you change it to debug view in here? Can you change it to debug view? Is it possible?
Not to keep the collab going.
Okay, well, you could probably open your DevTools anyway. And if you open your DevTools and change it to like an iPad or an iPad Pro, now you can see that it works with even touch inputs.
Yeah, just let's see. iPad Pro. Yep. Got it working?
Yeah. So getting it working for mobile, which might have been a huge task before, now becomes as simple as merging two streams of data. And there you go.
That's cool. Any other questions? No? Well, cool. David, I think we're good over here, man. Thank you so much for taking your time to present this to us and help us understand a little bit of RxJS and where we might want to use it and why. Yeah, really appreciate you, man.
Yeah, thanks for having me. And feel free to reach out to me on Twitter or anywhere else if you have any more questions about this kind of stuff.
Yeah, David's handle on pretty much everything is just David K Piano. So you can find him on Twitter and CodePen super easily there. Yep, he's changing it live there. So super cool. All right, well I'm gonna end the stream here in just a little bit. Thank you everyone who joined us on the live stream. And we'll have video available of this if you want to go back and watch and see see this again, so you can kind of understand it and code with it at the same time. So thank you so much, David. Really appreciate you guys, or really appreciate you, and really appreciate everyone that joined us live. We'll see y'all next time.
All right, thank you.
Thank you.